Hello, today we are going to do the Chapter 7 review. So, if you struggle with studying, hopefully this video will give you a hand. Alright, so number one, we're looking at this multiple choice question. And I'm not even sure what it's about, so I'm going to kind of read through it. Debbie is painting an image on a piece of art canvas. The image she is reproducing is 3 by 5 inches. She enlarges the dimensions 4 times. So she is looking at a picture, right? And she's making one on a piece of canvas that's bigger. Okay, so which of the following is true? The perimeter of the original image and the perimeter of the new image are related by a scale factor of 4. I like that one because when we're talking about perimeter, we can use the scale factor as is. All right, so I like this one when I read it through the first time. The area of the new image is 4 times the area of the original. I don't like this because when we're talking about area, we're thinking about that formula. The area of the new equals the area of the original times the scale factor squared. Okay, so we would have to do something to the scale factor. The scale factor here. Okay, we'd have to square it. So 16 is the number I would be thinking about when I'm thinking about area and scale factor. And that's exactly what H says. The area of the original image and the area of the new image are related by a scale factor of 16. I like that one. All right, so new scale factor, yep. And then the perimeter of the original image is 1/4 the perimeter of the new image. And that is true. The new image is larger than the original, so its perimeter would be 1/4 of the original. Or, yeah, that's correct. So I believe G is the right answer, because again we'd have to fix it, and I see the word area here. All right, so number two, another multiple choice. Which pair of polygons are similar? So I'm going to look for corresponding sides. So I'm going to go, I always find it easier to look at the smaller one and go to the bigger one. To me that is a ×2, but I have no other information about this other part. Okay, so there's nothing, I got nothing else to work with, so I can't say that they're similar. All right. Obviously these aren't similar because, they're not the same shape. B, I'm looking at this one. So I see an easy one to do. To go from 5 to 10 is a ×2. All right. This also looks to be the same, although it doesn't look like that's a corresponding side, but I could still argue maybe that that's a ×2, which means if that were true, this would have to be 8, and it's not. The other reason I don't like this one at all, like I would almost just go right to no, is it doesn't have any angle markings for me to actually compare sides. So I really don't like this one. I was thinking no anyway, but some of you might take this down that path and go, ooh, I think we're there. 4 times 2 is 8, but we're not seeing 8 here. So I don't like B either. That leaves me with D. And we'll see what happens. I got all the angle markings. I like that. To me, on the surface, it looks like that's going to be our similar triangle. Okay, but let's see. Let's make sure. So I'm looking at one angle mark here, and 2, 2, 3, 3, 2, 2. I don't have a 1. These both have 2 arcs. I'm going to guess that this is just supposed to be 1 arc. All right, so that's how I'm going to look at it. So from 1 arc to 2 arcs, we have 4 to 8, so that's a ×2. 2 arcs to 3 arcs, 2 arcs to 3 arcs, that's a ×2. 6 to 12 is a ×2. And 9 to 18, 1 arc to 3 arc, 1 arc to 3 arc, that is a ×2. So I am going to say the answer is D. And I better get moving because I'm already at 5 minutes in the video. Now, Mitzi is 64 inches tall and casts a 48-inch shadow. I see a shadow problem. I'm thinking that similar triangle or that indirect measurement. Okay, so I'm going to draw that. So 64 inches tall, shadow of 48. Okay, and then her daughter standing right next to her, she's casting a 30-inch shadow, but we don't know how tall she is. In fact, I'm going to call that Y. Okay, just because it's a vertical line. And I like setting up proportions here. So what I'm going to do is consistency is the key here. All right, I'm setting up my little, what's the word I'm looking for? My little template here. I have numerator, denominator, numerator, denominator. And I like to use each triangle in itself. So I'm going to go the height of Mitzi divided by the shadow, which means I have to go height now. I went height here, I got to go height here. That's why I don't know. And that equals 30. Okay? Now, push the wrong button. So I'm going to cross multiply. 64 times 30 is 1,920, and that's going to equal 48y. So I cross multiply to set that up. All right. Now, if you did this problem and you had a different setup, but you ended up with the same numbers, then you did it right. Okay. I'm going to divide that by 48. So I'm going to divide both sides by 48, and I'm getting y equals 40. So her daughter stands at 40 inches tall. All right. Number 4. The length of a rectangle is 18 centimeters and the width is 6. I'm going to draw that. So 18 is the length, 6 is the width. A similar rectangle has a width of 2. What is the second length? So we went from, maybe either think of it this way, we went from 6 to 2, which means we multiplied by a third. Okay. Or maybe that might be easier. How do I go from 2 to 6? Okay, that's 2 times 3 is 6. So what times 3 is 18? And that answer is 6. Okay, let me put 40 inches here. Another way to set that up is again to use a proportion. We could say the width over the width equals the length. I started with this one, so I got to start here. The length is x over 18. And I can cross multiply, which is 36 equals 6x. Therefore, x equals 6 is what we figured out there. Okay, 6, I'm assuming, centimeters. All right. So kind of an intuitive way to think about it, and then a proportional setup. Again, I went width divided by width equals length divided by length, and length divided by length, and I was consistent with how I did it. Small to large, small to large, small to large. All right. Number 5. We got to determine if these are similar or not. The way I think of this problem, I'm thinking in order to determine if two triangles are similar, I need to prove that two angles are congruent. Okay, so obviously angle C and angle E. Angle C is congruent to angle E because they're both 60 degrees. Okay, and now the tricky part is to remember from the last chapter that this angle B on both sides are congruent because they are vertical angles. All right, so I'm going to start at the 60 and I'm going to go CBA, angle CBA. I have to do that because angle B actually represents two angles, actually 4 angles. And so I got to specify which angle. CBA is congruent to, I started at the 60, so I got to start at the 60 here. EBD, angle EBD by vertical angles. All right. And then since 60 is congruent to 60 and B is congruent to B, these triangles are similar by angle-angle similarity. All right. Hopefully you could see that there. Pause it if that was off the screen. I apologize. All right. So I got halfway and I'm about halfway through. So determine if the two figures are similar by using transformations. Explain your reasoning. So I want to make sure all these sides are proportional, okay, or not congruent, proportional. So I see DC is at 2, and HI is at 1, 2, 3, 4, so that's good. So is AD, and so is FI. So I can clearly see that this is a dilation with a scale factor of 2. With a scale factor of 2. All right. And then that would mean that we make it larger by 2 and then we translate it and then we use a translation. So the dilation proves to me they're similar, and then I can translate that onto the FGHI. So that's how we can say yes, they are similar. All right. Rate of proportion comparing the rise over run for each similar for the similar slope triangle shown at the right. So I am going to pick these 2 points. And line AC is actually this triangle, ABC. So I can say that AB over BC, AB, rise over run, BC, should be equal to the measure of, and I'm going to use C and E, which would be CD over DE. And that tells me that AB is 2, BC is 2, that's rise over run, 2 over 2 is 1, and CD, 1, 2, 3, 4, hopefully this is 4, 1, 2, 3, 4, it is, and 1 equals 1, so the slope is 1. Oh man, I don't know if that was off the screen as well. There is what I was talking about. So I used the proportions of the triangle, the right triangles that make the rise over run. I got each value. Rise over run divided by rise over run, they equal 1 over 1. And again, if you look back from, I think it was chapter 4, rise over run, 1 over 1, 1 over 1. Oh, and I forgot one thing. That slope is negative because we're going down 1. So I should actually have those as negative. All right. Number 8, to determine whether the pair of polygons is similar using properties of similar polygons, explain your reasoning. So I am looking at, again, I'm looking for a dilation, all right? Am I multiplying the smaller by a number to get the larger? Okay, and so to get from 2 to 2 on the lengths, that's a times 2. To go to 1 to 2, that's a times 2. There's all 90-degree angles there, so yes, it is. And I can kind of show this as, you know, if I went from this rectangle, it has a scale factor of 2. So they are similar. All right, congruent. These are congruent. So write congruency statements comparing the corresponding parts. All right, so we got 6 of them. We're going to do each side and each angle. Okay, so I'm going to start with A to B. A to B is the 1 to 2. So that's line segment AB is congruent. Till I went 1 to 2, that's FG. Okay. And then I'm going to go BC, that's 2 to 3. BC is congruent to 2 to 3 is GH. Okay, and then I'm going to go 3 to 2, 3 to 1. That's CA is congruent to 3 arcs to 1 arc is 3 arcs to 1 arc is HF. Okay, and now the angles, because I can match these up with the arcs, I'm going to say angle C is congruent to angle H. I'm going to say that B is congruent to G. Angle B is congruent to angle G. And the last one, I think I haven't done the 1 yet, A is to F. Angle A is congruent to angle F. All right. Write congruent statements comparing the corresponding part. That was actually A, sorry. Describe the series of transformations that maps ABC onto FGH. So 3 is down there. I would say it's a rotation. So I got to get that angle C down here and that angle B up, and then a translation. So we're going to slide it after that. All right. 2 rectangles are similar. The length and width of the first rectangle is 4 by 5 meters. So I'm going to draw it. I always like to do that. 4 by 5. Okay. The second rectangle is similar by a scale factor of 4. What's the area of the second? There's a couple ways to do this. You could, in theory, do 4 times 4 is 16 and 5 times 4 is 20, and then just do 16 times 20. But really what they want you to do is use that formula. The area of the new equals the area of the old, which 4 times 5 is 20, times the scale factor squared. So 20 times 16 is 320. And that is the area for number 10, 320. Okay, do we have meters? Meters squared because it's the area. All right, triangle PQR's vertices 0, 0. I'm going to graph this P. Q, 2, 0, 1, 2, and 0, 2. 0, 2. So P, Q, R. All right. Reflect PQR over the x-axis, then dilate it by a scale factor of 2. So I'm going to reflect it and label the vertices of the image PQR. All right. So If I reflect it over the x-axis, that's this one, these guys aren't going